Hello everyone, welcome to our concept recap channel. In this video, we are going to introduce ordinary differential equations. And before we start, I would like to make a simple announcement, and that is regarding our email. We have an email here which is going to be on each and every screen of ours. So the use of it is for you guys if you want to reach me for help in this course and other science subjects. Use the email, I'll be able to respond. If you have public messages, you can also write in the comment section. I'll also respond to those. Let's now start with what we have today. Contents of this our topic today, introduction to differential equation. We're going to define what is a differential equation, and we are going to state the types of differential equations, and we are also going to look at order of ordinary differential equations. What is their order? It's a simple section, and also we have solutions of ordinary differential equations. So this is the most important part of this lecture. And lastly, we have tutorial questions where we are going to apply what we have learned in this video. So now let's start looking at definition of a differential equation. So the differential equation is an equation that contains some derivatives of unknown functions. So you have a derivative of unknown function. We will see what that means, but an example that I can give is this thing, f is equal to mass times dv dt. So this is an example of a differential equation. So you have dv dt, which is the differentiation of velocity with respect to time, and that gives you acceleration. So this is again written as F times ma. So you know mass times acceleration gives you the net force. So this is for physics. It's the law of motion. So it's just an example for you guys what is a differential equation, and you can see how important it is in science. So now let's start looking at the types of differential equation. We have mainly two types of differential equations, and we have ordinary differential equation and we have partial differential equation. We have here, guys, that an ordinary differential equation is the one that involves derivatives with respect to a single independent variable, and the partial derivatives, the one that involves with partial derivatives with respect to more than one independent variable. So what we mean by this is that if you remember that we in an equation we will have independent and dependent, so you have x and y. So it means here is this one is dependent and this is independent. So if you have only one x that is independent in that equation and you are differentiating it with respect to that one, then it's an ordinary differentiation. But if you have partial, then you have, maybe you may have time also here as an independent. So y depends on t and also depends on x. You differentiate with respect to one of it, the other becomes a constant. So an example I can give for you is that this dx dt is equal to minus kt. So this is an example of an ordinary differential equation because we only have one independent variable. So this is ODE. This is separable ordinary differential equation. Yeah. So we will see what you know. You learn also what is separable, and you have this, for example. So this is a partial differential equation. In this one, for example, if velocity is given by for example, is 2x plus 3y, and this is u. So to differentiate u partially with respect to x, what it will be? It will be 2, because this 3y becomes 0 and this becomes like this. So that's just to give you a recap on what we mean by partial differential equation. Now let's look at the order. Now let's look at the order of differential equation, and here it says that the order is basically the order of the highest derivative in the differential equation. So if I can give you this as an example, d squared x dt squared plus dx dt maybe plus x sine x is equal to 0. So if this is a differential equation, then the order of this one becomes what? It becomes the order of the highest. So it is second order. So you have got second order. So this is just basically what we mean when we say order. Now let's look at derivative notations. And on this one we have this notation, dy dx, and we have y dot, and also we have y prime. So these are the main. This is, they call it Leibniz notation. And this one, they call it Newtonian notation. You see some of these in different books. They use them interchangeably. And you have got this as the Lagrange notation. So these are the common notations of derivatives. So you see them in our differential equations. Now let's just look at the solutions of ordinary differential equations. So what it means is the solution of ordinary differential equation. For example, I have given these two examples. When you used to solve an equation like this, a quadratic equation like this, what were you doing? It was like, for example, this one, if you solve it factorization method, you find that x is equal to -1 and 3. So for you to test that these are indeed the solutions or the roots, then you used to substitute into the original equation, and if it's equal to the left hand side, then it's a solution. So for example, if we take 3 is equal to 0, then it gives us that then this is 9 and this is 6 minus 3, and then left hand side is equal to right hand side, then that is indeed a solution. So similarly, you do the same with our differential equation here. On this one, what you will do is that, for example, if I tell you y is equal to x is a solution, this function is a solution. So then you find what is a y prime. So y prime will be given the derivative of this, it will be 1, and this will be 0. So you substitute back into the original equation and see if it gives you, for example, if you take 0 minus x times 1 plus x is equal to 0, then you have 0 minus x plus x is equal to 0. Then left hand side is equal to right hand side. So that is a solution. So try if y is equal to 0. Try if this is a solution of this, is also a solution of this differential equation. So now, because of time, friends, I'm not going to solve the practice questions. I'll solve them in a separate video, but I'll give you a link where you can access the PDF of these tutorial questions regarding the order and solutions of differential equations, so that you can practice before you watch the next video. And see you in the next video, and goodbye.